everyone. Good afternoon, Abhay, Mohak, Astha. Quickly confirm if everything is working fine. You can hear me, see the presentation. I hope all good. All right, perfect. So understand that we would probably solve two odd sets based on knockout tournaments, but more importantly, think of this as a master class in trying to understand the variations that could possibly happen as far as knockout tournaments are concerned. So keep sharing your inputs, keep participating, keep responding. I'll be asking few questions in between once you are able to follow along whether what we are discussing makes sense or not. So hopefully we would probably have a very interactive session as well. But at the same time, understand that this is sometimes considered to be one of the more difficult topics to comprehend. A lot of people feel that this is sometimes very time consuming, if not difficult, sometimes a combination of both difficulty as well as time consuming questions. So my objective while discussing concepts in this session would be to make sure that you understand the stuff really well, so that at least the difficulty part is taken away, and then gradually move towards generating speed, so that if at all a similar set or some variations on questions that typically could come, we would be in a great position to be very confident about our ability to solve. So what is typically the duration for which we would continue? Approximately 1 hour or so. If required, we might stretch a bit, but I think approximately 1 hour odd should be good enough for us to discuss everything that I wish to discuss. At the end, we'll also look at an actual CAT set from the area of knockout tournaments. At least I'll share the screenshot. You can try it at home and get all the 4 questions right. That is my expectation, that we should be able to crack some of the previous questions that have been asked in previous year's CAT papers very easily. So I hope all good. Most of you are here. Let's start our discussion. So the first part is, where are knockout tournaments actually held? So if you look at Wimbledon 2026 and the last 3 rounds, you would realize that this is a screenshot of what happened in Wimbledon 2026. Jannik Sinner from Italy actually won the final, defeated Alexander Zverev from Germany. But typically you would see that this is an example of a knockout tournament, at least the last 3 stages. And you would see in chess, in tennis, in some of the other sports, that partially you might have certain stages as knockout stages, and some of the other stages at the start could be a league stages, or it could be a completely knockout tournament. So there are real life examples where knockout tournaments are based, and therefore expectation is that there could be a lot of questions that could be created around knockout tournaments, and therefore has been typically a part of the DILR syllabus, if I can say so, as far as CAT is concerned. So now moving ahead, what is it that we are going to do? Understand that I'm going to show you a set along with 5 questions. So this is a set, 1 paragraph related data and then 5 questions. Our objective as part of this session would be to be able to answer these questions with utmost ease, irrespective of the fact whether we know anything about games and tournaments right now, or whether we are an expert. Doesn't matter. We should be able to answer 5 questions with a lot of ease and should be able to get answers very quickly. So what is it that we are going to do now is understand the paragraph, understand how the knockout tournaments proceeds, what are the terms and jargons. So for some of you this might be very easy. So please bear with me for the first 10 odd minutes. It might seem very easy, but gradually we are going to touch the level of difficulty that is expected in CAT and beyond. So we'll go slightly above the level of expectation that CAT might throw at us. So everything would be there. Just a little bit of patience would be required at the start. I've shown you the set and the questions, which is typically the objective. Now let's build our theory for the same. All right. So let's start with some important terms that we need to understand before we proceed to knockout. So the first part that we need to understand is the concept of seed. So understand, whenever you talk of seed, it is essentially the same as rank. It is essentially the same as rank. So when you say a 32nd seeded player, you are saying that the rank of the player is 32. And typically rank 1 is called as the highest seed, and this is where some of you might get confused, because when we look at the term highest, we tend to think of a larger number. So understand, when it comes to rank, which is the best rank that anybody could possibly get, it is rank number 1. I would want that most of you would try to get that rank 1 in CAT as well. That would then be converted into percentile, and you would get that 99.99, 100 percentile and so on. So understand that we would say highest seed would be rank 1, and let's say there are 16 players. So then 16 would be called as the lowest seed or the lowest rank. So whenever you come across this term rank, understand that this refers to seed, and highest seed is the best rank. So think of it this way, that this is the best rank, and this typically is the worst rank that you could possibly have if there are only 16 players. There could be 16 players, 32 players. Generally, you would find that the number of players are of the form 2 to the power n, and we'll realize very quickly why is that the case. We'll also take an example, what if the players are not of the form 2 to the power n. So I'll try my best to cover all eventualities, all variations, all possibilities, but at this stage just understand the concept of seed. Seed is same as rank, highest seed, lowest seed we have understood. Then the part on upset. So what is an upset? Suppose there is a player, and understand that these ranks are decided before the tournament starts. So before any match is getting played, we know the ranks of all participants, all players. And now what will typically be called as an upset? When a poorer ranked player beats a better ranked player. So typically the term that I tend to use is poorer ranked, because numerically high low you can get confused. Think of best and worst, think of poor and better. So poorer ranked player, if poorer ranked player beats a better ranked player, then we would say better ranked player, then we would say this is typically called as an upset. Just as an example, suppose we have a match between player rank 3 and player rank 10. Now the general expectation is player rank 3 is a better player based on past performance, so he is expected to win. Who is the underdog? I'm pretty sure that most of you would be familiar with this term underdog. Who is the underdog? 10th rank player is the underdog. He is not expected to win, but suppose player rank 10 wins the match. If player rank 10 wins the match, then we say this match resulted in an upset. So now I have a question for you. Very quickly share this in chat so that I'll know that you have understood what is the meaning of upset. Suppose there is a 5th rank player and this player plays a match against 12th rank player. Who should win so that it would be called as an upset? Who should win so that this is called as an upset? Perfect. Thanks, Mohak. Darsh, Arshya, Astha, Shruti, a lot of people, Kavish, Shriyukta, Ananya, Lukesh, Abhay. I might have missed a few names because of the scroll. Bharat, absolutely correct. So player rank 10th should win, so that we would call it as an upset. So now upset as a term is clear. Seed as a concept is clear. Now let's also understand, what do you mean by a knockout tournament? So understand, when we say knockout, the meaning of this term is getting eliminated. It is getting eliminated. So why is it called a knockout tournament? The moment a player loses a match, that player gets eliminated. For example, suppose in round 1, there is a match between player ranked 1 and player ranked 16. And player rank 16, let's suppose, loses. So then this person would be eliminated from the tournament. He cannot participate in the next round. That player is gone. It is only player that wins will be allowed to proceed to the next round. So we'll assume that 1 has won. The player ranked first has won. So player rank 1 will proceed to round 2 to play a match. So I hope, why is it called knockout? I hope this is clear. Knockout means elimination. So anybody who loses, the moment you lose, you are eliminated. So you won't get another chance. Whereas if you compare this with league stage or round robin or for example IPL, you would say that initially everybody gets to play with everybody else as a home match, as a away match, and then a points table is constructed. Nothing like this happens here. You play a match, you win, you move to next round, you lose, you get out, you are eliminated. I hope this much is absolutely clear with regards to the basic terms that we needed to understand. Now typically understand that because whenever a match happens, so understand this concept that whenever a match happens, the match always happens between two players, just like any other match, and therefore one match would require two teams, and because it is knockout, one player would get eliminated, one would go forward, and therefore to be able to have proper matches getting scheduled across all rounds, you would want the number of players to be of the form 2 to the power n. So typically get familiar with these numbers of 2 to the power n, which are 8, 16, 32 and so on, 64, 128. These are all higher powers of 2. So understand these are the number of players that we would start with, because then it becomes very easy to schedule the tournaments, because you'll be able to do half every time till you get the final one winner. So now what we are going to do is understand the scheduling structure, assuming there are 2 to the power n players. So let's start with this. So let's take an example where there are 32 players. Now typically how is the scheduling done? So understand for round 1, match number 1 would happen between the best ranked player and the last ranked player. So if I take an example where there are 32 players, so players would be ranked from 1, 2, 3 and so on up till 32nd rank. Which is the best ranked player? First ranked player. Which is the worst ranked player? 32nd ranked player. So match number 1 would happen between 1 and 32. Think of these as the rules. So what we are currently understanding is the set of rules, the way scheduling is done. All this would be given in the question data set. But imagine reading an RC and then trying to understand what it says versus understanding the context and jargons already, so that it would make our life much easier. So currently we are understanding those standard rules which are there for knockout tournaments. More often than not, these are the kind of rules that you would get. But as I said, we'll discuss variations if at all the set is difficult, what could be the possible variations. So rules are that the best player plays with worst player in match 1. Second best ranked player plays with the second worst ranked player, which is 31 in this case. So 2 would play with 31. Match number 3 would happen between third ranked player and 30th ranked player. So 3 would play with 30 and so on. Now I'll want you to understand based on this, is there a pattern that we could get for the numbers that we are getting here for every match? Can you find a pattern? The pattern should be fairly simple. If you add the ranks, 1 plus 32 is 33, 2 plus 31 is 33, 3 plus 30 is 33 again. Therefore, can I say that I could directly write that sum of ranks for round 1 would be equal to 33? I hope this pattern is clear. If this is clear, then can you quickly tell me in chat, player ranked 10 would play a match against which player? Player ranked 10 would play a match against which player in round 1? The sum total has to be 33 for the ranks. Perfect. Excellent. So player rank 10 would play a match against player rank 23, so that the sum of ranks as a pattern is continued. 10 would play against 23. Now I'm going to quickly fill the table on these lines, assuming that everybody has understood what is happening. So player rank 15 would play against which rank player? So 15 should be added to what number to get 33? So we'll say 18. 15 and 18 is 33. Player rank 16 would play against player rank 17. So this is how the scheduling for round 1 typically happens when you have 32 players. Now very quickly, just take a moment to pause and think. I've taken 32 players. What if there were 64 players? Then how would the scheduling happen? Player rank 1 would play against 64, perfect. 2 would play against 63, 3 would play against 62. The sum total for ranks would be 65. So understand, whatever is the last rank player in that particular round, the sum total is +1 to that. So if 32 players are there, 33 would be the sum total. Now what would happen in round 2? Now round 2, because is dependent on the winners of round 1, only the winners can proceed to round 2. Losers get eliminated. So we don't know who are the winners. There could be any of the winners. Now if anybody can win, then let's try and figure out a general structure that is given in questions to understand what could be the scheduling in round 2. Round 2, match 1 happens between winner of match 1 and winner of last match, which is the 16th match. So understand, 16th match is between player rank 16 and 17. So winner of match 1 would play a match against winner of match 16. So previous rounds, look at the previous round. Previous rounds first match winner and previous rounds last match winner would play against each other. Now think of it this way. What are the possible combinations that we could have for match 1 of round 2? So can I say we could easily identify that the winner could be anyone among 1 and 32 because of match 1. So if you look at just match 1 and match 16, can I say from match 1 I could have 1 or 32 as the winner, and from match 16 I could have either player rank 16 or 17 as the winner. So two possibilities in W1, two possibilities in W16. I can illustrate them and say there could be 4 possibilities. 1 would play against 16, 1 could play against 17, 32 could play against 16, and 32 could also play against 17. So these are the 4 broad possibilities that we could have. So round 2, match number 1, there could be 4 possibilities. Similarly, there could be 4 possibilities here as well. And similarly, there would be 4 possibilities everywhere else as well. So how would match 2 happen? Match 2 would happen between winner of match 2 and winner of match 15, the second match and second last match. Now let's assume one interesting condition, which is, let's say there are no upsets. Let's say there are no upsets. If there are no upsets, then can I say all the 4 possibilities trickle down to just one possibility? Because now we would know that among 1 and 32, 1 would definitely win because there is no upset. So all the better ranked players would definitely win. So can I say, I can remove these 3 possibilities and say there would be just one possibility for the match 1 that would happen between winner of match 1. All these possibilities would get eliminated. We would just have player ranked 1 playing with player ranked 16. Is this part clear to everyone? How will round 2 match 1 happen if we assume there are no upsets? Why? Because 1 playing with 32, if there is no upset, 1 would win. 16 playing with 17, there is no upset, 16 would win. So 1 and 16 would play against each other. In match 2, again, just one possibility, 2 would play with 15. All the top 16 ranked players would come here. So now if we try and find the pattern, 1 plus 16 is 17, 2 plus 15 is 17. So can I say for round 2 again, we would get the pattern for sum as 17. So far so good. No confusion here whatsoever. Now this is how the tournament would proceed. Now it's a good idea for us to assume no upsets till round completes, till the entire tournament gets completed, just to get familiar with how the progression or the scheduling would happen. So what I'm going to do next is just give you a picture with no upsets. Assuming there are no upsets, then how would the typical tournament look like? So if we look at this with a scenario of 16 players. So what are the conditions that we have assumed? We have assumed 16 players. And we have understood that there are no upsets. So if there are 16 players and there are no upsets, this is how typically our schedule would look like. That round 1 would have match number 1 between 1 and 16, match number 2 between 2 and 15. You could take larger number of players as well, just like we took 32, but just so that every information is available on the slide, I've taken lesser number of players. Believe me, we are going to solve a set with 512 players, and then you could try it for 1024 players, 2048 players, and so on. Any powers of 2 you would be able to solve. So don't worry about larger numbers. This is a smaller example so that we understand the logic, and then we can apply it anywhere irrespective of the level of difficulty. So type yes quickly if this structure is clear to everyone, that there are 16 players, no upsets. Just look at standard learnings that we could have. Learnings being sum total in round 1 would be 17, in round 2 sum would be 9, round 3 sum would be 5, in round 4 sum would be 3. And this is how the scheduling would look like. No confusion whatsoever. The important assumption here is no upsets. And we would also understand the scenarios when there are upsets. So we'll go gradually, just have patience. That will cover all those parts when there are upsets as well. So what will happen? Perfect. So far so good. This is the typical structure that we would have. And again, if there are no upsets, understand that one would win the tournament because one is the best ranked player. So 1 and 2, the final match would happen and eventually one would win the tournament. Now based on this, what are some of the standard questions that we could answer very quickly? So if we move ahead, first standard question that comes to mind is find the total number of matches in the tournament. So we are solving it for just the smaller scenario of 16 players, but we'll generalize this for any number of players of the form 2 to the power n. So what could be a standard way to attempt this question? We can say in round 1, there are how many matches? Match 8 is happening. So understand if there were 16 players at the start, half would be the number of matches. So round 1 we had 8 matches, M1 to M8. What about round 2? So round 2 we would say there are 4 matches. Round 3 we have just 2 matches, and round 4 finally we just have 1 match. So if we add these values up, 8 and 4, 12 and 2, 14 and 1, we get our answer as 15. Now this is a slightly lengthier way to solve this question. Can there be a direct approach to get an answer to this question of 15? One is to manually count 8, 4, 2, 1. So we now know the correct answer, but this is lengthier. Is there a shorter way? And if at all there is a shorter way, can we generalize it across the spectrum of total number of players? So let's see. So think of total players as 16. Total players as 16, which is 2 to the power 4. So can I now say that my answer is just 1 less just by observation? So let us think in this direction. Why is the answer 1 less? Will this always be true that the answer would be 1 less than total players? So think of it this way. Every player except the one player who wins the tournament would lose 1 match and get eliminated for sure. For example, player rank 2 would lose in the final and get eliminated. So there will be a count of 1 match for player 2 where this person is getting eliminated. Player rank 3, assuming no upsets, would lose in match 2 of semi-final. So can I count this as 1 match where player 3 is getting eliminated, player 4 is getting eliminated? So look at all the matches that you are able to see, and I am now highlighting these matches for which player is getting eliminated. So in the final, you would have player rank 2 getting eliminated. In the 2 semi-finals, we would have 3 and 4 getting eliminated. Then in the quarter-final, we would have the players 5, 6, 7 and 8 getting eliminated. Can I say in every match one player is getting eliminated? All players are going to get eliminated? All 32 players? All 16 players? No, not all 16 players are going to get eliminated. One player will never get eliminated. So which is why that one is not counted, and we could directly say that for all the other players we can count 1 match where they are getting eliminated. So simply said, we could say total players minus 1, 15 would be our answer, and therefore to generalize this as a formula, if total number of players are given as let's say P, which in turn is equal to 2 to the power n, then the number of matches would always be players minus 1. And if players are of the form 2 to the power n minus 1. Now understand whether the players are of the form 2 to the power n or not, this relationship holds true. This relationship holds true for any number of players. So for example, even if you have odd number of players, prime number of players, the number of matches would be 1 less, because understand, except the winner of the tournament, everybody else has to get eliminated. So type yes if this first question is absolutely clear to you. Fantastic. Thanks. So first part, total number of matches, done. So very quickly, as I move to the next slide, in between, please do share. What if the total number of players are, let's say, 128? So suppose we have 128 players, then what would be the number of matches? Quickly, number of matches typically would be, fantastic. Let's move ahead to the next question. The next question is similar. It says find the total number of rounds in the tournament. So the question is asking find the total number of rounds. Now again, think of round 1 where we had 16 players, then round 2, round 3, round 4. It is but obvious that based on the structure that we have created, the number of rounds are equal to 4. But can we generalize this? The total players we had were 16. 16 is 2 raised to the power 4. So if 16 is 2 raised to the power 4, this part of power or index or exponent, whatever term you may want to call it, this part of 4 is our actual answer for number of rounds. Which means if I give you this next question, that the number of players, if I give you this next question, that if the number of players are, let's say, 64. So can you tell me the number of rounds that would happen? Can you tell me the number of rounds that would happen if the number of players are 64? So we would say this is fantastic. 2 raised to the power 6, number of rounds would be equal to 6. All good, everybody on board with this? 64 is 2 raised to the power 6, our answer would be 6. Let's move ahead to the next part. So this was about the second question, number of rounds. So we have understood two crucial parts. One is number of matches, second is number of rounds. Let's move ahead to the next part now. So let's look at the next question. The next question is slightly more interesting, difficult, challenging, and I would say more on the lines of what cat might throw at you. So let's look at this question. They are saying find the minimum number of upsets required in the tournament such that the player seeded 7 wins it. Now believe me, a lot of good aspirants even would find this question slightly challenging. I won't say very tough, but slightly challenging. What we are going to do is understand the answer for this question assuming 16 players, and then we would generalize it across the spectrum so that it becomes very easy irrespective of the number of players. So let's see how to approach, and what is the question saying? Minimum number of upsets required in the tournament. So there are two important parts. One is this part of minimum upsets, and the second part required in the entire tournament. So whatever matches are happening currently, so we have 15 matches in this particular structure. Across these 15 matches, we want minimum upsets. I hope we understand upsets is when a poorer ranked player beats a better ranked player. We want player seeded 7 to win it. So we want player rank 7 to win it. So should we try with player rank 7? Let's straight away try with rank 7. So player rank 7 without any upsets can reach this stage of round 2. Player rank 7 would play against player rank 10 in round 1. Look at this. So in round 1, players 7 and 10 would meet, and 7 is a better ranked player, so we don't need an upset, and if no upset is there, player rank 7 would automatically reach. So in round 1, there are no upsets required. Player rank 7 is still on board, reaching quarterfinal. But the problem here is that player rank 7 is playing a better ranked player, player rank 2. So now can I say that 7 would definitely require an upset here? Let me write U here, that player rank 7 would definitely require an upset. Some of you would argue, sir, there is a chance that 2 might lose. So 2 might lose in the previous round and 15 might come up here. So then 7 would not be required to cause an upset. Agreed. But then if 2 loses here, can I say this would be an upset? Match 2 would then be an upset. So either you would require an upset in match 2 or you would require an upset in match 2 of round 2. Round 1 or round 2, you would definitely require an upset for 7 to proceed further. So can I say, think of it this way, that we would shortlist the stage till the time this particular ranked player is able to reach without any upsets. So if I assume that there are no upsets in round 1 because I wanted to minimize the upsets, there would definitely be upset required in round 2. Now if round 2 is an upset, 7 would take the place of 2. in match 2 of round 3. And now 7 is going to play a match with 3. So can I say this would again be an upset? This would again be an upset. And 7 beats 3. So 7 would then take the place of 2. 7 would be playing against 1. If 7 is playing against 1, again you would require an upset. Again you might argue back saying, sir, there is no need for us to have 3 here. Instead of 3, we could have 6 here. So you would require an upset then here in match 3 of round 2. Any which ways, you will require one upset in that scenario, and therefore can I say we can make this very easy to think logically that first identify the stage where that particular ranked person is able to reach without upset. So that particular ranked person in our case is ranked 7, able to reach round 2 in quarterfinals without any upset, and then from that onwards he would require an upset in every round. So he would require an upset in round 2, he would require an upset in round 3 and round 4. So therefore can I say the minimum number of upsets required, the answer for this question would be 3. Now this is a logical way to solve this question, which is we have understood that we would require upset in each of the rounds after a particular round. So this is clear. For example, if somebody had asked us player rank 12, so what will be the minimum number of upsets required? So we'll say the 12 rank player will require an upset in round 1 as well, and then in all the subsequent rounds. So the answer for player rank 12 would then be 4. Now this is all good in terms of logic. Can we make this faster? Can this be done much quicker? So answer is yes. Typically, when you have a rank of a player, can we generalize this answer as 3? How? Think of the next higher power of 2. Think of the next immediate power of 2 given to that rank. So I am sharing a standard shortcut which is based on the logic that we have just understood, which is player rank 7 was available to us. What is the next number which is of the form 2 to the power n immediately after 7? So if we look at powers of 2, we can say 2, 4, 8, 16, 32 and so on. So I am looking for powers of 2 greater than 7. The immediate next power is 8. So I will typically write this as 7 is less than or equal to 8, the next immediate power of 2. What is 8 as power of 2? It is 2 to the power 3. So when you look at this power or index or exponent which is 3, this is your answer. So understand, this is a fantastic shortcut for you to calculate the minimum number of upsets required in the tournament. Minimum number of upsets required in the tournament. Just look at the next higher power of 2. For example, suppose the question says instead of player seeded 7, the question says player seeded 20, and there are, let's say, 32 players or 64 players, and the question is asking about player seeded 20. So what I am going to do is look at the next power of 2 which is greater than 20. So 2 to the power 4 is 16, 2 to the power 5 is 32. The moment I know that immediate next power is 2 to the power 5, the minimum number of upsets required for this question would be 5. If this is clear, next question is for you. Assume that the number of players are large enough. Tell me what would be the minimum number of upsets required for the player ranked or player seeded 35 to win the tournament. Assume 64 players. So what would be the minimum number of upsets required in that case? If player rank 35 is to win the tournament, minimum number of upsets required in the tournament. Just look at next power of 2. Fantastic. Very good. Very good. Reds, Darsh, Bharat, Mohak, Arsha, Ananya, Ashwin, all correct answers. Fantastic. So next power is 64, which is 2 to the power 6. Very quickly, next question is if the rank of the player, last question for this particular category, if the rank of the player is, let's suppose, 13. So what would be the minimum number of upsets required? Rank 13. So now you would be able to solve question irrespective of the number of players. Rank 13. Fantastic. Rank 13 would be very good, 16. So this is 2 raised to the power 4. So the correct answer for this question would be 4. So now we have understood a magical shortcut to get answer within seconds. You throw the number, you'll give the answer for minimum number of upsets. So this part is clear. If you are able to understand, follow along, just share this in chat. It would be a great motivation to continue with the same momentum that we have been able to build so far. So we have understood the minimum number of upsets category of question. Let's look at the next question. So we have already understood this. You could create a table like this and understand the general rule to be able to get the answer. If we move ahead, next question typically is find the minimum number of upsets required to be done by the player seeded 7 himself. So this is even more difficult now to understand, and we'll first understand the difference between this question, minimum number of upsets required to be done by the player seeded 7 himself so that he wins the tournament. So what is the key difference that you see here? The key difference is upsets required by the player seeded 7 himself. You could give herself as well, himself, herself, doesn't matter. So find the minimum number of upsets required to be done by the player seeded 7 himself. How is this different from the previous one? There we could have upsets across the spectrum of the tournament. Anybody could be a participant in that upset. But here we would want to count the minimum number of upsets which are required to be done by the player. So we will only count the upsets. We would only count the upsets which the player himself is involved in. So let me illustrate this with an example, and for sake of convenience I have reduced the number of players to 8 because it would be convenient if we look at smaller values and then we would stretch it to any number of players. So let's start with player ranked 1. What are the minimum number of upsets that the player himself would be required to participate in? So we would say this answer is clearly 0. Player ranked 1 is the best ranked player. He doesn't need to get involved in any upset himself. What about player rank 2? A lot of you would be tempted to answer this question as one that player rank 2 is able to reach the finals without any upset. This player rank 2 would be involved in one upset himself. So player rank 2 here would cause an upset. So for 2 the rank is 1, but this is wrong. For player rank 2 the minimum upsets are 1, but this is wrong. 1 is not the correct answer. Let's think why. The earlier discussion that we had, that let other players get involved in upsets, would be applicable now. So understand this. What if we have the previous rounds match between 1 and 4, resulting in an upset? So can I say 1 would lose here and 4 would take the place of 1? So I'll say 1 would not be available, 4 would be available here. So then 2 would play a match with 4. Now understand the journey of 2. 2 was playing with 7, not required to be a part of upset himself. 2 is playing with 3, not required to be a part of upset himself. There is another match in semi-final that is getting an upset. We don't bother about that because the question is himself. Is that player getting involved in upset? No. What about this match? 2 is playing with 4. Will this be an upset? No. And therefore, can I say with guarantee that minimum upsets required by the player himself would be 0 here? That the player is not getting involved himself in an upset. There would be other upsets in the tournament. We are okay with that. Type yes if this is absolutely clear. That for player 2, the minimum number of upsets would be 0. If this is clear, then we can move forward with player rank 3 as well. So now let's focus on player rank 3. We can have other upsets in the tournament. We don't want 3 to be a participant in the upset. So player rank 3 is able to reach semi-final. Playing against 2. Can I have an upset in the previous round where 7 takes the place of 2? So then 3 would play against 7. And now 3 would take the place of 2. Here again I could have an upset and player rank 4 could come in. So 3 would play 4, 3 would play 7 and 3 would play 6. In none of the 3 matches that 3 is participating in, we would say that there is an upset that he is himself involved in. I would say the answer is 0. So we are doing this for all the 8 players, if at all there are 8 players, and then we would generalize it for 16 players, 32 players and so on. But so far, if there are exactly 8 players, then is the condition for top 3 ranked players being 0? Is this clear? Let's quickly look at player rank 4 as well. If you look at player rank 4, we don't want player rank 4 to himself cause an upset, which means here player rank 4 should not play against player rank 1. Our objective should be that. So can I have 8 winning from here? Yes. This would be an upset, but we are not bothered with this upset because player rank 4 is not involved in this. We want player rank 4 to win the tournament without himself being a part of an upset. So player rank 8 would come in here, and then 4 would play against 8, would win this and take the place of 1. Now 4 could possibly play 2, but again we could have 2 and 7, 7 winning, 7 against 3, 7 winning. So we could have a 7 rank player here. So again for 4 it is 0. So far so good. Now let's look at player rank 5. The problem with player rank 5 is, what is the problem? Problem with player rank 5, we should try for 0 upsets here as well, but the problem is in the first round itself, the first draw that is there, we cannot have previous round before this. There are exactly 8 players. So in the first round itself, 5 is playing a better rank player. So there is no option except for player rank 5 to cause an upset here to be able to move to next round, to be able to win the tournament. So we will definitely require one upset. Let's take the scenario where player rank 5 beats player rank 4. So he would take this spot. Now you might feel that this again would be required an upset 1 with 5. No, we could have 8 playing against here. So 5 and 8 would play here. And then instead of 1, 5 would be reaching the final by beating 8. This is not an upset. Again, instead of 2, could we have 7? Yes, 7 could move to semi-final and then 7 could come here as well. So 5 would play against 7. So again, in final and in semi-final, player rank 5 does not need an upset. It is only in round 1. So we would say minimum upsets required here would be 1. Minimum number of upsets here required would be 1. If this is clear, let's move ahead to player rank 6th, and now I can run through this fast. That player rank 6 again unfortunately is in round 1 scheduled against a better rank player. So player rank 6 would definitely require an upset here. So 6 would take the place of 3 by beating 3. Playing against 2, can we have a poorer rank player? Yes, 7 could be here, so no upset required here. 6 would take this place, here we could have 8. So again, only one upset is required for 6. Moving ahead, let's try it for 7 now. So if you look at player rank 7, so what will happen with player rank 7? Player rank 7 would definitely require an upset himself here. Player rank 7 would take the place of 2. 7 is playing against 3. Now who is 3 playing against in the previous round? 6. So even if we have an upset in the previous round, the worst ranked player that we could have is 6. So there is a problem with 7 in semi-final as well. The best condition for 7 is 7 plays against 6. Then again it's an upset because 7 is a poor ranked player. So there would be an upset required in semi-final as well, or second round as well. And then in this case 7 can reach by taking the position of 2. Here we could have 8. So in the final 7 will not be required because there is at least one poor ranked player playing him in the final. So if we want to minimize the number of upsets, we could say 7 would require 2 upsets. Now finally, let's look at the last ranked player. Can I, without solving, say that player rank 8 would definitely require 3 upsets? Why? Because player rank 8, just observe, is the worst ranked player. In the entire list of 8 players, 8 is the worst ranked player. So whoever he faces against would be an upset. So he would play one match in round 1, that would be an upset. And then he would move to next round replacing 1. So 8 and 4 again is an upset. This was an upset. And then 8 would take the place of 1, again an upset. So can I say across all the rounds, all matches, 8 ranked player is the worst ranked player and therefore would require 3 upsets. Now this was very time consuming, and this is why typically aspirants tend to shy away from games and tournaments, especially knockout, because who will do all this mix and match of trying to go back to previous rounds, thinking how many upsets are required? If the player himself is involved, there is a lot of counting to be done, and as if 8 players were not small enough, what if there are 128 players, 256 players, 512 players? So you would feel a sense of trouble because of the time consumption thing. Let's make this very, very easy. Now understand the approach to this very, very carefully. Please be very focused. I am now telling you how to fill this table for all the players who are participants in the tournament for this particular category of question, minimum upsets that the player himself is involved in. What you need to do is observe that if we take 8 players, can I say half of the players, look at this half, the first half of the players, the first half of the players don't require any upsets. So this first half of 4 players don't require any upsets. So what you are supposed to do, whatever be the number of players, divide them into half. The upper half will not require any upsets. Then for the bottom half, again divide it into 2 parts. So I'll divide this and I'll change the color of pen so that it's clearly visible. So divide this into 2 parts again. So what I have done for these players 5, 6, 7 and 8, I have divided them into 2 halves. So the first half would require 1 upset. Then whatever is left, again divide it into 2 halves. So if I now divide this into 2 halves, the list of players that I would get would be 7 and 8. The next would get 2 upsets and the last would get 3 upsets. So again I am explaining what is going to happen. Suppose we take 16 players. So then without the need to solve anything, how do we calculate the minimum number of upsets required by the player himself? So the table is in front of you. You will divide the table into 2 halves. So first 8 players are the first half and all these players would require 0 upsets. No upsets required. They'll win the tournament because somebody else had an upset. What will we do now? So these 8 players, I hope are clear, will require 0 upsets. Now for the remaining bottom half, we would again halve this. So for players from 9 to 16, divide them into 2 halves. So this would be at the range of 12th rank. So now we have divided them into 2 halves. All the players from 9 to 12 would require exactly 1 upset to be able to win the tournament. And now for remaining players from 13 to 16, again you would divide them into 2 halves. So 13, 14 would get separated. For these 2 players 13 and 14, you would require 2 upsets. Again the last 15, 16 will have to divide them into 2 halves. So if we divide them into 2 halves, 15 would require 3 upsets and the last rank player 16 would require 4 upsets across the 4 rounds. So player rank 16 would require an upset here, would require an upset here, 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 because 16 is the worst rank player. So 16 would take the place of 1 here, 16 would take the place of 1 here, 16 would take the place of 1 here. So this 4 we had deduced logically for 8 players earlier. Now for 16 players, I hope you get the pattern that keep on dividing the table into halves. Start with 0 upsets for the first half, then 1 upset for the next part of the half, then 2 upsets, then 3 upsets and so on. Type yes if this is absolutely clear to you. Believe me, this is fantastic. If you can understand this, remember this, it will save you tons and tons of time. Imagine now, if this is clear, I'm going to ask you a simple question. And the question is, suppose there are 32 players. If there are 32 players, can you tell me what would be the minimum number of upsets required by the player himself? Minimum upsets required by the player himself to win the tournament for, let's say, rank number 13. Can you tell me this quickly within seconds? Minimum upsets by the player himself, where player himself is required to do. So just think it in your head. You will divide 32 players into 2 halves and then calculate. So for player rank 13, what would be the answer? For player rank 13, what would be the answer? Fantastic. Very good. Ashwin, Mohak, Reds, Arsha, Ananya, Bharat, the boys, Sriyukta, Darsh, Ritu, Satakshi, Abhay. Correct answers, all of you. Fantastic. So player rank 13, minimum number of upsets that the player himself would be required to participate in would be 0. And very quickly, if I asked you for player rank 32, so understand player rank 32 would require an upset across each of the 5 rounds. Remember, this is the last rank player, 32 players are there. So 2 to the power 5 will have 5 rounds. Minimum number of upsets required by the last rank player would be 5. So far so good. No confusion in this. Perfect. So if this much is clear, and you can take a screenshot, maybe take a screenshot later on if you are going to watch the recording. But if you take a screenshot, this can go in your formula notebook in understanding knockout tournaments for 2 different conditions: minimum upsets, overall in the tournament and minimum upsets required by the player himself. Now let's move to the next part. This is again a super challenging question. I'll try my best to first explain the logical way and then create a ridiculously easy way out so that we could get the entire list. Let's look at this question type. If upsets are allowed, alright, find the list of players, all players, who could have played with player ranked 3 in the semi-final. So I've taken 16 players just to understand the question, and then we would apply it as usual to larger number of players. So this stage is the semi-final. This stage at the second stage is your semi-final, and player rank 3 is here. So who could have played player rank 3 in the semi-final? Let's go via the logical approach. So player ranked 3, who are the opponents that player rank 3 could have? So for player rank 3, the list of opponents clearly is a player rank 2. They are asking who all could play player rank 2 in the semi-final. So obviously we have a structure where there are no upsets. So player rank 2 definitely is a possible opponent. But if we backtrack and look at where player rank 2 is coming from, so player rank 2 is playing a match with player rank 7 in the previous round. So can I therefore say if 7 beats and upsets are allowed? They have said we don't know whether upset would happen or not, but they are allowed. So we will have to take this possibility that upset can happen. If upset happens, then player rank 7 can also face player rank 3. So can I say the two opponents that we have definitely identified are 2 and 7? So far so good. But these 2 and 7 are also playing a match in the previous round. So 2 is playing a match with 15, and if you look at 7 is playing a match number 7 with 10. So can I say 10 could also win here? 10 would take the place of 7 and 10 would win here against 2. 10 could again take the place of 2. So 10 is a possibility. I hope all of you are with me on this. And similarly 15 is also a possibility, because if 15 beats player rank 2 in round 1, then 15 would go in round 2. 15 would play against the other people and so on. So the other set of players that we can identify by backtracking are 15 and 10. So for this smaller question, this is our answer. Question done. 2, 7, 15 and 10. Very easy. But it is easy and not very time consuming because we took only 16 players. Imagine 512 players. Then we'll have to backtrack to previous round, then look at all the totals and so on and stuff. So is there a shorter way to attempt this question? And you will have to draw this without upset kind of a structure to be able to visualize this. So with 16 players, it is still manageable and easy to draw. Imagine 512 players, you are not expected to create the entire draw. That itself would take 40 minutes. So no point in drawing that entire draw. So how do you navigate this question easily? I hope the logical way is clear, that you go backtrack, look at all the players who could have possibly played, and 2, 7, 15 and 10 could possibly play player rank 3 in the semi-finals. Now, one logical way is to identify the sum total after you've identified the first 2 primary players. So let me give it a name. Primary players that possibly could have played, and this list of primary we can identify because we have created a structure of no upsets, and 3 would play 2, and in the previous round 2 would play 7. So primary players are the first 2 players that you are easily able to find based on just the immediate previous round. The starting point, think of it as your starting point. Now how to go about calculating the next set of players? So understand that we have a pattern for sum total of ranks to be equal to 9. So can I say you could go ahead like this, that the sum total of ranks is 9. So sorry, sum total of ranks is 9 in this round where we are getting 2 and 7, or if we move ahead to the further round, we would get a sum total of 17. So what should be added to 2 to get a total of 17? 15. This is why 2 and 15 we are playing a match, because the total was 17. And what should be added to 7 to get a total of 17? So we would say 10. So you could go logically by tracing just the sum total as a number, and we can remember the sum total like the number of players plus 1. So if in the final we talk, final you will have the sum total as 3. In the semi-finals, the sum total would be 5. In the quarter-finals, you will have a sum total of 9. In the round of 16, you will have a sum total of 17. So all these numbers are 2 to the power 1, 2 to the power n plus 1. Next total would be 33, 64 plus 1, 65, 128 plus 1, 129, 256 plus 1, 257. Just remember these totals that we have already identified. So as an example, suppose I now extend this. Suppose I extend this question to 32 players. This very question to 32 players, and I don't need to look at this structure except the part on the first two primary players. I don't need to backtrack till 32 players. I don't need to draw. I want to again find player ranked 3 would play which all people in semi-final. So I want to know this. So what I'm going to do is look at the primary players. I've already identified the primary players as 2 and 7 from the previous example. This much we'll have to do. 2 and 7 are the primary players. Now the next part is very easy. Just go by sum total. Here the sum total is 9. So we have already taken the case for sum 9. What is the next total after 9 that we are going to get in pattern? 17. So for next set of values, find the numbers that are complement of 2 and 7 such that they give a sum total of 17. So what should be added to 2 to make it 17? We'll get 15 and 10. So far so good. But if there were more players, how do we go about further? So after 9 and 17, what is the next sum in the previous round that we would get? So in the previous round, we would get sum total as 33. So for all these 4 players now, for all these 4 players, you need to find a complement to these numbers such that sum total is 33. In other words, think of what should be added to 2 to get a sum of 33. So you would say this number would be 31. For 7, what should be added to 7? So we'll say 26. What should be added to 15? So we'll say 18. And what should be added to 10? So 23. So this is the list of 8 players that you have who would have played with player rank 3 in the semi-finals. Is this pattern of sum of ranks clear to all of you? That we have done sum total based on the total number of players plus 1 in that particular round, and we have just taken complements based on the primary players. So first we identified 2 and 7, and once we were able to identify 2 and 7, we identified the total of 17, so we got 15 and 10. Now we have 4 players, so complement of these 4 players for the sum total of 33 will get 4 new players, which means had there been 64 players, then can I say sum total of 65 would be done for all these 8 players. So you would get 8 more new players, total list would be 16. So this is another logical way to do this. I hope this is absolutely clear to everyone. So this is another way. Now as usual, we are going to find a very, very magical shortcut so that we could populate the list of players without worrying about anything except focusing on primary players. So if you want to take a screenshot, take a screenshot for this way. And now I'm going to share with you the generalized way to answer this question in the form of a pattern. So we want to focus on player rank 3. The bare minimum that you need to do, is find out 2 things. First thing you need to do is find out primary players. And second thing that you need to do is count of players while these primary players are playing against each other. That's it. So let me explain. What are primary players? We have already understood this earlier. We want to find who will play against player rank 3. So we said obviously 2 would play, but we just go one round before and we say 2 and 7 are playing against each other. So we say primary players for this particular case are 2 and 7. This is easy. And what is the count of players when these 2 primary players are playing? So maximum number of players in this round are 8. So count of players that we get as 8. That's it. These are the 2 things. And now you have the entire list of players irrespective of the number of players. How? Your base players are 2 and 7. Now just keep on adding 8. Just keep on adding 8. So if I add 8 here, 2 plus 8, 10, 7 plus 8, 15. This is the next list of players. So just keep on adding 8 as a sequence. 10 plus 8, 18, 18 plus 8, 26, 26 plus 8, 34, 34 plus 8, 42 and so on. 15 plus 8, 23, or you could observe a gap of 5 and then calculate. So you'll have 31, you will have 39, you will have 47 and you can go on like this. This is the entire list of players depending on the range that you want to calculate to. So for example, if there are only 32 players, this is the list. Quickly cross check and type yes if you have got the same list using this pattern. 2, 7, 10, 15, 18, 23, 26, 31. Is this the list of players that we got earlier? If yes, also share whether you have been able to understand this. What have we done? We have understood the primary players and we have understood the count of players when these two primary players are playing against each other. And why is this happening? It's a simple rule of number theory that all the other previous rounds, the sum total would increase via multiple of 8. The difference between 17 and 9 is 8. And if you go further, it would be 16 and so on. It would always be a multiple of 8. So the remainder left when you divide these numbers by 8 would be 2 and 7 always. Look at all these numbers. Dividend is equal to divisor into quotient plus remainder. That is the simple concept that is getting applied here. On dividing all these numbers by 8, you would get remainders of 2 and 7. So fantastic application of number theory in games and tournaments to be able to create a magical shortcut. So now I am going to take one more example where suppose I am asked who would find out the entire list of players, list of all players playing against player ranked 1, playing against player ranked 1 in finals. So the way I am going to approach is it, in final 1 is playing against 2, but in the previous round who is playing, 2 and 3 are playing. So can I say these are my primary players? That's it. And you would only be required to create the draw or visualize this in your head for semi-final and final. So 2 and 3 are the primary players that I've got. And what are the total number of players available in the stage where primary players are meeting each other? 4. So now the gap that I would have would be a 4. So 2, 3, 2 plus 4, 6, 7. Then 6 and 4, 10 and 11. Then 14 and 15. Then 18 and 19 and so on. You can write down all such sequences till 64, 128, 256, the number of players that are given. In general, you could write a generalized relationship for them as 4k plus 2 and 4k plus 3. If you are given 4 options, which would normally be the case, you could just check whether given options are of the form 4k plus 2 or 4k plus 3. I hope this is clear. So again, if required, rewatch this recording, rewatch this question where if we are asked who would play against player rank 1 in the finals, so the primary list of players, the two players which are very easy to find are 2 and 3. The total players when 2 and 3 are playing against each other are 4. So the format for all players would be of the form 4k plus 2 and 4k plus 3. Just keep on putting k as 0, 1, 2, 3 and so on till infinity, you will get the entire list of players depending on the total players. So if there are 60, for example, if there are 32 players, please don't say that player rank 34 would also play. Obviously, player rank 34 is not a part of the list. So we'll have this list till 31. So stop till you get the cutoff of the total number of players available. So this, and now you could answer all such variety of questions that could possibly get asked based on this. So again, I would say that as far as I'm concerned, I found this super useful, and this is typically not available at a lot of places as well. If you just try and figure out whether you have studied this, I would say very few places where I have been able to find such unique approaches to solving these questions. So make a note of this, revise them, and if at all anything like this comes, you would be in a great position to answer questions confidently. Let's move ahead to the next part. This is a question for you as homework. In a knockout tournament with 64 players, you could change the rank of the player here from 3 to maybe let's say 2 and try it out. Share your answers in the comments later on, and I'll be happy to take up your doubts if any in the comments, or reply to your answers whether they are correct or not. So if you take this question as an example, 64 players, list of all players who could have played with player rank 2 in the semi-final, share the answer. Again, a homework question from my side, which is the question that we started with. 512 players are playing. What are the total number of matches, total number of rounds, minimum number of upsets required for players seeded 100 to win, lowest seeded player to win the tournament without himself herself causing any upset, which means 0 upsets required for the player. So what could be the lowest seed of such player if 512 players are there, and list of all players that player ranked 1 could have played with in semi-final if upsets are allowed. Again, these 5 questions are your homework. Try them out after the session ends. Share the answers in comments. Share if you have any doubts. I'll be more than happy to interact with you there as well. Moving ahead, this is the last part as far as today's session is concerned, which is about buys. 2 simple questions typically come based on buys, and this happens when you have players not of the form 2 to the power n. So when players are not equal to 2 to the power n, typically you would require a concept of buy. You would require a concept of buy. Why? Because if you move further, you will get an odd number of players somewhere in some other round, and then you will not be able to schedule matches between corresponding players. Let's take a simple example. Suppose we have 23 players, 1 being the highest seed and 23 being the lowest seed. They are saying in round 1, and this is the standard condition that we get. This is slightly different from what you typically get in 12th standard NCERT physical education, 12th standard CBSE physical education paper. So just a word of caution, what we get for CAT and what has historically appeared in CAT, the condition for buys is slightly different from what you might have studied if you have studied physical education paper and the concept of buys. So this is slightly more different than and slightly difficult than what you see in your 12th board's physical education paper. So top seeded players are given a buy. So they've clearly said that whoever are the top seeded players, top seeded would be best rank 1, 2, 3. So whoever are the best ranked players are given a wildcard entry. So you don't need to worry about who will get a buy. Top seeded players will get a buy, so that no more buys are required from second round onwards until the end. Now understand, if we have 23 players, what is the problem? Suppose I go by normal scheduling. So I'll have 1 with 23 playing against each other, 2 will play with 22 and so on. But who will play with 11? Who will play with 11? So we'll say 11 will play with 12. 11 will play with 12. Will 11 play with 12? No. Look at the sum total of ranks. Sum total of ranks is 1 plus 23 is 24. So 11 would play against 13. Who would player rank 12 play against? 12 would have to play against himself. So then you might say, sir, give this player rank 12 a buy, and then we would have top 11 players moving to the next round. But then again, you have odd number of players. So this would create a lot of scheduling issues. So what the question typically does is, it says that top seeded players are given a buy so that no more buys are required from second round onwards. So from second round till the end of the tournament, no more buys are required, which means what? Which means from the second round onwards, we would have players which are of the form 2 to the power n from second round onwards. Round 1, we just have 23 players that is given. But from round 2, we would have players which are of the form 2 to the power n. Among the remaining players, the highest seeded plays a match against lowest seeded. The rest of the structure is same. These are the 2 standard questions that we need to understand. Now, let's see how to approach. So, be very careful and attentive while you are listening to this. Round 1, we have 23 players. Round 2, can you think, pause for a moment, think about it. What could be the number of players in round 2 so that no more buys would be required? What do you mean by buy, by the way? Buy is when a player directly moves to next round. Moves to next round without playing a match. So it's like a wildcard entry. So let's say player rank 1 is given a buy. So player rank 1 will not play a match in round 1. It will directly go to round 2. Wildcard entry directly into round 2. So from round 2, we know that the number of players that we want are of the form 2 to the power n. So what is that number lesser than 23 which is of the form 2 to the power n? So we'll say 16. So we would definitely have 16 players from round 2, so that 16, 8, 4, 2, 1, entire theory remains intact after round 2. So if there are 16 players, can I say from 23 to 16, 7 players are getting eliminated? 7 players are getting eliminated. Now if you have understood the theory for knockout tournaments well, you would realize that one match results in one player's elimination. If we want 7 players to be eliminated, can I directly say therefore 7 matches would be required? From 23 we are down to 16 players. because 16 is the next available power of 2. So 7 players are getting eliminated. If 7 players are getting eliminated, we would require 7 matches. So for the first part, what is the total number of matches in round 1? We have already got the answer 7. Now, what are the total number of players who are given a bye? So think of round 1. Round 1, we have said 7 matches. So there would be a match 1, match 2, match 3 and so on till match 7. Let's populate this table till match 5, match 6, match 7. So these are the 7 matches that would happen. Understand that each match requires 2 players. So can I say these 7 matches would require 14 players to play a match, which means these 14 players are not going to get a bye. So in round 1 we had 23 players, 14 players are playing a match, so rest of them are getting a bye. So 23 minus 14, can I say 9 players would get a bye? This is our answer for second question. Just to understand this, think of it this way, that the top 9 seeded players, 1, 2, 3, 4, 5 and so on, till 9 are getting a bye. So who is the best ranked player now? 10th. So 10th ranked player would play against 23rd ranked player as match number 1. 11th ranked player would play against 22nd ranked player. 12 would play against 21, 13 would play against 20, 14 would play against 19, 15 would play against 18 and 16 would play against 17. So this is the list of players who would be participating, and the top 9 players above them would get a bye. So this is the logical way we have answered both the questions. We have understood how to approach questions based on bye, but again this is still time consuming because we have to think, okay, these many were the players, which are the next number of players of the form 2 to the power n, and these many matches would be required because these many players are getting eliminated. So double of them would be required in terms of playing. Subtracting remaining takes some bit of time. Logically, this is the best way to understand what is happening. But now let's again, as usual, create a magical shortcut. So what were the number of players? The number of players that were given to us was 23. And these are the 2 standard question types that typically come, if at all they come. One is number of matches and second is number of players that got a bye in the first round. So that second round onwards there are no byes. What you have to do is just identify the powers of 2 that 23 lies between. So 23 lies between 16 and 32. Is this part clear? 16 lies between 23 and 23 lies between 16 and 32. So then how did we identify 16 and 32? The powers of 2 between which this number 23 lies. Now we don't need to do anything, just take the difference. 16 and 23 is what? 7. This is your answer for first question. Difference between 23 and 32 is 9. This is your answer for second question. Which means, let me take a different example. Suppose there were given 79 players. Suppose there were 79 players in round 1. So what will be the number of matches and how many players would be given a bye? I'll just identify 79 lies between which 2 powers of 2. So 2 to the power 6, 64 and 128. So what would be the number of matches required? So simply 79 minus 64, that is how much? 15. And what would be the number of byes given? So 79 and 128, the difference would be 21 plus 28, 49. I hope this is clear. If this is clear, next question is for you. Tell me the answer for both questions and then we'll wrap up the session. If I'm giving you total number of players are 51. If total number of players are 51, tell me the matches required in first round. Tell me the matches required in first round and also tell me the number of byes. Matches required in first round and also the number of byes required in the first round. 51 lies between which 2 powers of 2? Just observe. You can do it mentally. Lies between 32 and 64. Fantastic. Very good. So the answer would be 19 matches and 13 byes. Fantastic. You can practice more questions on your own if you feel like. And this is again a question that you could take a screenshot of to practice more. You can share the answers in comments. Quickly take a screenshot if you feel like. 19 and 13 are correct. Alright. Now this is an actual set from CAT 2005. Take a screenshot. You can practice and get the answers for 4 questions on your own. There are 32 players. Whatever we have done right now is understand this entire RC. So whatever is given in this paragraph, we have already covered this. We don't need to worry about the conditions. Just quickly read it once so that there is no confusion. But this is something that is already known to you as part of theory of knockouts. And they have given names to the different ranks of players. And this is way back from 2005 women's tennis. And therefore you will find names like Maria Sharapova being seeded as 1. So this was from CAT 2005. These are the 4 questions. Quickly take a screenshot. That's all that I had planned for today's session. We have slightly exceeded the duration of 1 hour, but I hope this is good enough as far as the topic is concerned. So I sincerely feel that this added a lot of value. After the session, please do share in comments your feedback as well. If you have any, do share definitely the answers for the questions that I've given you as homework. And we'll meet again soon in some other session later on. Also do share in comments if you want any particular session across QA, DILR, even VRC that you would want to be taken up in some of these sessions that can add value, that is causing trouble when you're preparing on your own. Thank you, Arsha. Thank you, everyone. I'll take a leave.